Alrighty, today's lesson is going to be on special right triangles. First, I will introduce 45, 45, 90 triangles as well as 30, 60, 90 triangles and the relationships between their sides. And then I'll model some practice problems as well. And then you can check your understanding by practicing two as well. And we'll move on from there. So the first one I want to talk about is a 45, 45, 90. This is an isosceles triangle, which we have seen before, and we know it's an isosceles triangle because it has two equal legs and two equal angles. And those angles would have to be 45 degrees each, because if we know that's a 90-degree angle, there's 180 degrees in a triangle. These would both have to be 45s. Okay. So if we look at these guys here, we have two legs, and then we also have a hypotenuse. We're going to put the hypotenuse in blue. Here's the hypotenuse, and we know that's the hypotenuse because it's opposite the right angle. When we talk about 45, 45, 90 degree triangles, it is always the case that the legs are equal to each other. Okay, and when we compare that to the hypotenuse is always square root of 2 times longer than the two legs. So you'll hear me talk about this in the video quite often. The way I like to think about this is that it has an a to a to a square root of 2 ratio. So it's the case that if I know one of these sides, I would know them all because the legs are equal to each other and the hypotenuse is square root 2 times longer than the legs. And we can go either way, forward or backwards, to find the missing side lengths. The next one I want to talk to you about is a 30, 60, 90. Now, 30, 60, 90 is a little bit trickier. I'm going to fill in the missing angle measurements. This is the 30-degree angle. This is the 60-degree angle. Now, there's three sides. We have the hypotenuse, okay? We have a short leg, and the reason I know it's the short leg is because it's opposite the 30-degree angle. And then lastly, we have this thing called the long leg, and the long leg is always opposite the 60-degree angle. So we have a short leg, which I'll abbreviate as SL. We have a long leg, which I'll abbreviate as LL, and then we have the hypotenuse. Okay, so like I said, this long leg is in green, the short leg is in yellow, and the hypotenuse is in blue. It is always the case that these are related in a certain way. So if I know one, I know them all. Okay, so my short leg, if that has a length of A, we'll call it A. Okay, the long leg is always square root of 3 times longer than the short leg. The hypotenuse is always twice as long as the short leg. So they're all related to the short leg, okay? The long leg is square root of 3 times longer than the short leg, and the hypotenuse is twice as long as the short leg. And this is the relationship you'll see in all 30, 60, 90 triangles. So let's do a couple examples together, okay? We have a 45, 45, 90. Okay, and what I wrote down before was that these are related as an A to A to A square root of 2 relationship. And what I mean is that the two legs are equal to one another, and the hypotenuse is square root of 2 times longer than the legs. Okay, the hypotenuse is always opposite the right angle, so this would have a length of A square root of 2. And the legs have lengths of A. And making this connection and labeling these sides helps us figure out where everything else belongs, because what we can do is that we know that A equals 4 because that's a leg. So we have that A equals 4 and we can use substitution. This would mean that W equals 4, and this would mean Y equals 4 square root of 2. I'm just substituting in for the A's, because A equals 4. W equals 4, and Y equals 4 square root of 2. I can't simplify 4 square root of 2 anymore. This is my final answer. In the next problem, it's a 30, 60, 90 triangle. And we wrote down before that those are related as if I know the short leg, the long leg is square root of 3 times longer than that short leg, and the hypotenuse is twice as long as the short leg. So we match up the sides. The hypotenuse is represented as twice as long as the short leg, which I'm calling A in this case. The short leg is always opposite the 30 degrees, and I'm going to let that guy be A. And then lastly, the long leg is square root of 3 times longer than the short leg. This is the side that we have information about. So let's make that connection. A would equal 2. Now I can solve for W and Y by substituting. We know W is A square root of 3, but we just said that A is 2. So I substitute. 2 square root of 3. I can't simplify this anymore. I can't multiply anything together. We want our answer to be exact, so we're not going to round. We're going to leave it in simplest radical form. So W would just equal 2 square root of 3. The hypotenuse, which is in blue, which would be Y, is worth 2 A's. Well, we just said A is 2, so I substitute. We're substituting in for the A's that we have here. Okay. 2 times 2, I can simplify. We know that that's 4. So in this case, x equals 2 square root of 3 and y equals 4. And that problem is done. It is always the case that they relate in this way if it's a 30, 60, 90. I also knew that this missing angle that's not in here is a 30, because if we have 60 and we have 90, okay, and these three angles have to add up to 180, that has to be 30 degrees. Let's work on a problem that we're going to have to do a little bit more work for in simplifying radicals. This is a 30, 60, 90. If this is 30, this would have to be 60. Oops, probably help if I put the pen on. So this is 60. Okay. We know in a 30, 60, 90, they're related, as if I know the short leg, the long leg is square root of 3 times longer than that, and the hypotenuse is twice as long as that one. Let's label our sides. We're so good at finding a hypotenuse. It's always opposite the right angle. Even though this picture is flipped around, we can find that the hypotenuse is here. Well, this last one represents the hypotenuse. It is the longest side. That would make sense. The short leg is always opposite the 30 degrees. So here's 30. The one across from it would be here. So that means that the short leg is in green. And lastly, the long leg is opposite the 60-degree angle. There's the long leg. So let's start solving with what we have from here. No, I don't want the highlighter, I want a pen. So the one that we have information for, we know that we're solving for this guy because it equals y, and we're going to be solving for the purple guy because that equals x. So we're going to use the blue side to solve. We know that the long leg has a length of 12, which represents square root of 3 times longer than the short leg. That should be an equal sign, sorry. So we want to solve for a, because once we solve for a, we can just easily substitute into these two equations here, or expressions. So we have 12 equals a times the square root of 3. You're going to want to divide each side by the square root of 3, because you want to get a by itself. Those would cancel. So I'm left with a equals 12 over the square root of 3. My equal signs are not coming out. That's okay. We do not leave our answers like this. We need to rationalize the denominator, and this is something that we've learned in previous math classes. To rationalize a denominator, we're going to multiply the top and bottom both by the square root of 3. And the reason I can do this is because it doesn't change the value of 12 over the square root of 3, because multiplying by the square root of 3 over the square root of 3 is the same as multiplying by 1. The only thing that's going to help us here is that when we multiply the square root of 3 times the square root of 3, we can get rid of the square root symbol, sign. So we have 12 times the square root of 3. And we have the square root of 3 times the square root of 3. Well, these guys are both under a square root right here. We can multiply those together. The top ones are not, so we leave them separate. So we're left with the square root of 3 times the square root of 3. But the square root of 3 times the square root of 3, which I just rewrote, so silly. Sorry, I meant to put them under the same. But we know 3 times 3 is 9. So now I'm left with 12 square root of 3 over square root of 9. But we know that the square root of 9 is 3. Okay, and we finally have our square root out of the bottom, which is what we wanted to do. That was our goal of rationalizing the denominator. However, we're not done yet. If you notice, the 12 and 3 are both outside of the square root. That means we can simplify it. 12 divided by 3 is 4. So this complete answer is that A, because we did start off with trying to solve for A equals the 4 square root of 3. So now I can start substituting. We know that Y equals A because it is the green side, right? It's the short leg. The short leg is what we're looking for. We'll call it Y. We're solving for Y. But we know that it has a length of what we call A. And you don't have to use A's. You can use whatever letter you want. You just want to avoid reusing a letter over here. And sometimes when you get really good practice at this, you won't have to set up any equations. You'll just see it. Y equals the 4 square root of 3. That is the measurement of side Y. It's the green one. Next, we want to solve for the hypotenuse, which would be x. We know x equals 2a. We substitute. So that means x equals 2 times the 4 square root of 3. We can totally simplify this guy, okay? We know that 2 and 4 are both outside of the square root, so we can multiply those guys. 2 times 4 is 8. So I'm left with 8 square root of 3, and that's what x would equal. Okay, so x equals 8x equals 8 square root of 3, and that would be my final answer there. Y equals 4 square root of 3, and that problem is complete. On the next slide, I want you to pause this video to check for your understanding. Just pause this, work on these two problems on your own time, and when you're ready, unpause it and see if you got it correct. So in the first problem over here, it's a 45, 45, 90, and I know that because these two are equal. Okay, so that means we're going to an A to A to A squared root of 2 ratio. The legs are equal to one another. The hypotenuse is square root of 2 times longer than those legs. So if we know that the A square root of 2 equals 6 square root of 2, we want to solve. We want to get the A by itself. Divide by the square root of 2, divide by the square root of 2. A would have to equal 6, which would mean that W equals 6 and Y equals 6. I don't know why my equal signs are not coming out, sorry. That problem is complete. The next problem is a 30, 60, 90. They have a relationship as if I know the short leg, I know the long leg is square root of 3 times longer, and I know the hypotenuse is twice as long as the short leg. We want to match up the sides. The long leg is always opposite the 60-degree angle. The short leg is always opposite the 30-degree angle, which we can assume is 30 because the angles in a triangle always add up to 180. And lastly, the hypotenuse is twice as long as the short leg. We use the one we have information about. We know the hypotenuse is 10. And we know that that hypotenuse is twice as long as the short leg. So let's solve for the short leg. A would have to be 5. Once we know this, we can substitute. The short leg is W, which we know is the length of 5, because it just equals A. Y would have to be 5 square root of 3. All I am doing is substituting in for those A's. Alrighty, and that concludes